So this is my Rube Goldberg type of video. So you have Team Avatar is flying on Appa's back until Appa got tired, so they decided to stop on the nearest island. The island has a lake that seems to be filled with some unknown liquid. Katara wants to determine the density of this liquid, so she submerges a block in it and finds that when she submerges it, 5 centimeters are submerged in the liquid. Then when she tries to submerge it in water, the block also floats, but now there are 7 centimeters that are submerged. Then we are asked, Katara wants to know what the density is. So to solve this problem, first you will need to find what the volume displaced is for the block in the unknown liquid and in the water. And once you find that, since we're given the height of how much the block is displaced in each liquid, we would be able to solve for what the density of the unknown liquid is, since we know what the density of water is. So while Katara was finding the density of the unknown liquid, Zuko and Iroh take a break from looking for the Avatar and make camp at sea level. They decide that they're going to use some flames to heat some water to make it turn into a gas. They decide to place a constant volume gas thermometer in the gas, and they wait until it reaches its equilibrium point. Once the equilibrium point is reached, the pressure is equal to 6,000 pascals. After this, Zuko moves his thermometer from the cell that has the water gas or water vapor into a different cell that has a different gas sample. And so after he moves it, the pressure changes to 7,000 pascals. So what is going to be the temperature of the thermometer after Zuko moves the thermometer from this cell to this cell? In order to solve this problem, we would have to use the ideal gas law and use all the values that we were given in order to find what the temperature of the thermometer when you move it from here to here is going to be. So after Zuko and Iroh have done some playing with fire and heating up gases, and Katara has found what the density of the unknown liquid is, Sokka starts missing his ex-girlfriend the moon, so he decides to visit her. On his trip to the moon, he takes a mass, a 40 centimeter long spring, a meter stick, and a stopwatch. The spring stretches 5 centimeters on the moon with the mass attached. And with his stopwatch, he finds that 5 oscillations take 14 seconds. G on the moon is about 1.625 meters per second square. So with that information, how many grams is the mass that Sokka decided to take on his trip to the moon? So we have this spring, that's the spring that Sokka decides to take, and then when he gets to the moon and the mass is on the spring, it stretches an additional 5 centimeters. So we know what the value of G is, of what G on the moon is, but we don't know what the mass is. And so this is what we're trying to solve for, and finding this, we would be able to solve for what M is. Since we're also given how many oscillations can be done in 14 seconds, we could use this to find what the period is. And so with all the information that we are given, we would be able to solve for mass.